Hello students, a very big hi to all of you from my side. How are you all? I hope you are doing absolutely well. So, in our previous lecture regarding periodic classification of the elements, we have gone through many topics, and in this discussion, we have gone through about the characteristics of the S block elements, that how they will show their different characters. We have discussed about the P block elements and the D block elements. Now, let us move to our next topic, that what are the characteristics of F block elements. So, our topic is characteristics of F block element. We have characteristics of F block element. So, F block elements generally going to represent the last two series, that is the horizontal rows that is present below the periodic table, that we known as lanthanoid and actinoid. These series will be basically represented by the F block elements. Now, what will happen in the case of F block elements? When the last electron is going to enter in the n-2 shell of a F orbital, we say that it is an element of the F block element. It is counted in the category of the F block elements. So, what will happen in this case? When last electron enters in n-2 shell of F orbital, we can say that this is an element of F block element. So, this will represent F block element. So, that element is going to represent the F block element here. Now, what will happen next? The group third elements, the element that belongs to the group third in the periodic table, is usually the F block elements. So, elements of group third are F block elements. This is the another specification for F block elements. Now, moving to the general configuration of the F block elements, we have the general configuration of the F block elements, and that is general electronic configuration. So, the general electronic configuration for such kind of elements will be n-2 F1 to 14 n-1 D0 to 1, and it will be NS2. So, this will going to specify the general electronic configuration for F block elements. Now, F block elements are basically known as inner transition elements. So, what will be the another name of such kind of elements? These are known as inner transition elements. We will call it by the name inner transition elements. Now, the two horizontal rows that is basically present between the bottom part of the periodic table, it means it has been separated from the periodic table because it has actually the properties different from all of the components present there. So the two series that is present in the bottom part of the periodic table, that is lanthanoid and actinoids, is going to represent the F block elements. So our next point will be two horizontal rows present at the bottom of periodic table are F block elements. So these are actually the F block elements that is present in the bottom part of the table. Now this F block elements is actually divided into two series. So what are the two series here? It has been divided into two series. Now these two series will be lanthanoid series and actinoid series. So the two series we have is lanthanoids and actinoids. Now this lanthanoid and actinoid series basically consist of 14 elements. It means this series consists of the 14 elements is going to start from lanthanum, that is its basic element, lanthanum, atomic number 57, and then after this the basic element it may start from cerium to lutetium. Then it comprises of the 14 elements in total. So we can say that both of the series consist of 14 elements. This consists of 14 elements. This also consists of 14 elements. So if they both comprises of the 14 elements, we can say that total elements in the F block series will be 28. So the total elements in F block is total elements in F block series is equal to 28. That is 14 plus 14. So this is a general thing about F block elements. Now this lanthanoid consists of the 14 elements and this is basically starting from lanthanum. It is going to start from lanthanum and this lanthanum is having a atomic number 57. This atomic number 57 is the starting element of the lanthanum series, and similarly this actinoid series is going to start from actinum. It is going to start from actinum, and this actinum is having an atomic number 89. It means the second row is going to start from atomic number 89. Now after lanthanum, this series is going to be completed from cerium to lutetium. This will be comprised of the elements from cerium to lutetium, and after 57 cerium will having an atomic number of 58 only. Now considering this elements, it will be from thorium to it will start from thorium to lawrencium. So it will going to represent the lawrencium element, and thorium will having an atomic number of 90 here, and this will having an atomic number of 58 here, because after 57 the series is going to start from 58 only. So we can say that the series that is starting from lanthanum having atomic number 57 is known as lanthanoid series, it comprises of the inner transition elements, and the series that is going to start from actinum, that is atomic number 89, is known as actinoid series. So these are the two basic thing about these special series. These are special series. Now, these lanthanoids and actinoids, that is the F block elements, are showing the unique behavior. So they also possess some special characteristics also. The first characteristic is that these type of the compounds of the F block elements is having a very high density, very high melting point. They have the variable oxidation state. They usually form the colored compounds. So the general features are, they have high melting point. The melting point of such compounds is very high. Second point is, they have high density. The density of such compounds is again very high. Next thing about this F block elements is, they form colored compounds, or they form colored components. So they form colored components. And next point is, they again show variable oxidation state. And the last feature or the last characteristic about the F block element is this. You see that there is an actinoid series. So some of the actinoid elements are basically used as a radioactive elements. So we can say that some of the elements of actinoid are radioactive in nature. Some elements of actinoid series are radioactive in nature. So you can see here, these are some of the general features of F block elements we have discussed here. So these are some of the general features apart from these characteristics. So you can see that it is all about the F block elements, and in general we can say that these are usually the inner transition elements consisting of two horizontal rows. One is lanthanoid and one is actinoid. Now, after all these characteristics, let us move to our next topic, that we will going to represent all these SPDF block in the form of the block diagram. So it may be easier to learn and you are capable of understanding it in more easier way. So let us move to the block diagrams of these elements. So next topic we have that is block representation of SP, D and F block elements. Now we have seen that the first and the second group elements are usually the S block elements, and then after there is a long gap in the periodic table, the horizontal part usually represent the D block elements. Then again we have the P block element, and after P we have the inert gases, and in the bottom part of the table we have discussed that we have the inner transition elements that is separated from the periodic table. So let's understand such kind of representation with the help of the block diagram. So let us start here. Now we have drawn a periodic table that is in the block form representation. Now these first two blocks is going to represent what? These are actually S block elements. These are S block elements. And this is again S block elements. This is first group and this is second group. These are usually known as S block elements. And what will be the another name for such kind of the elements? We can call these elements as a normal elements or representative elements. So these are known as representative elements. These both are known as representative elements. And the general configuration, that is the general electronic configuration for the S block elements is NS1 to 2. Configuration of these elements will be NS1 to 2. So this is the characterization of this S block elements, that these two blocks will going to form the S block elements. Now you can see here, this part is not a P block. This horizontal part that is lying horizontally in the periodic table is actually D block element. This is D block. So this is our D block element. These are D block elements. And what will be the another name for the D block elements? D block elements are known as transition elements. These are known as transition elements. Their general electronic configuration is N-1 D1 to 10 NS2. So this will be the electronic configuration for D block element. Now let us move to our next block. This part is going to represent P block elements. This is P block elements. The another name for the P block element is again representative elements. These are again representative elements. Now, what will be the general electronic configuration for such kind of compounds? Configuration I am writing here. The general electronic configuration for p block elements will be NS2 NP126. This will be the electronic configuration of such compounds. Now, apart from this p block element, what is this vertical line or the vertical block is going to represent? This block usually represented a line which is actually our noble gases. So, this will going to represent our noble gases. So, this block is for noble gases. Noble gases are also known as inert gases. And what will be the general electronic configuration? They have completely filled octet. So, the general electronic configuration for such compounds will be NS2NP6. 6 plus 2, 8. It means their outermost shell is fully filled. Now, let us move to this horizontal block. This horizontal block is actually the F block elements separated from the periodic table and placed at the bottom part of the periodic table. So, this is our F block elements. These are F block elements, and the F block elements usually known as inner transition elements. These are inner transition elements. Now, in this inner transition elements, we have general electronic configuration, and the general electronic configuration for F block elements will be N-2, F1 to 14, N-1, D0 to 1, and NS2. So, this will be the general electronic configuration for F block elements. So, you can see that this is the block representation for all the SPDF elements we have discussed here. So, it might be easier to you to learn the periodic table in this block format. So, you can copy this block format from here, so we can deal with another topics in this system. Now, starting from here, we have noble gases. Noble gases we have are also known as inert gases. So, we can say that I am writing it here, noble gases. So, let's discuss about noble gases first. So, noble gases are also known as inert gases, rare gases, and another name for the noble gases is aerogens. What are they called? They are called aerogens. And you can see here NS2NP6 outermost electronic configuration is going to represent that they have their completely filled octet, but one exception lie here, that is helium. Helium is having an electronic configuration NS2 only, so it is not going to form an octet, it is going to form the duplet because it has an electronic configuration that is equal to 2. So, this is all about the noble gas representation. And the noble gases we have will be helium, neon, argon, krypton, xenon and radon. These are the noble gases we have. And these are known as aerogens. So, it is about the noble gases. Now, this P block, S block and this S block is going to represent the representative elements, but this figure is not counted in the category of the representative elements. These are called the representative elements because they have their outermost shell not completely filled. They have their stable electronic configuration, but the outermost shell is not going to be filled in the case of representative elements. So, move to the next category. The next category is about representative elements. Representative elements. Then What are the representative elements here? The representative elements are usually from S and P block. Representative elements are from S and P block, but except noble gases. Noble gases will not be counted in representative elements. Except noble gases, and this type of the representative elements usually have outermost shell not completely filled. Outermost shell not completely filled. Now, after representative elements, we have the another block, that is D block element, and the D block element is going to represent the transition elements. So, why the name transition elements have been given? You can see that in the D orbital, the first electron goes to the n-1 orbital. It means this is a half filled orbital, or we can say that these are the degenerate orbitals. So, in this category, these elements are known as D block elements because they have not their completely filled stable configurations. But apart from this, there are certain elements like zinc, cadmium and mercury. These elements are the elements of D block elements, but they are not called transition because they have not their half filled orbitals. So, let us move to the third category, that is D block element. So, after these noble gases and S and P block elements, we have our third category, that is transition elements. We have transition elements. Now, in the category of the transition elements, we have the D block elements, and the electron will going to be enter in the half filled orbital. It means they have the half filled orbitals, therefore they are known as the transition element. But one exception is there. The exception here is that zinc, cadmium and mercury. These are the three elements. These three elements is actually belongs to the D block elements. These three elements are the elements of D block. These are elements of D block. But the exception is that they are not known as transition metals because their outermost shell, or we can say that they do not have a half filled orbital. So, these are D block elements but not transition elements. And why they are not called transition elements? Because of their incomplete d orbital, because they do not have half filled orbitals. So, this is about the transition elements. Let us move to our next category. The next category is about inner transition elements. What are inner transition elements? The inner transition elements we have discussed currently, that this is going to represent the bottom part of the periodic table having the electron filled in the F shell of the n-2 orbital, and this is usually represented by lanthanoid and actinoid series. So, lanthanoid and actinoid is going to form the inner transition elements. So, they have lanthanoids and actinoids. They are going to form the inner transition elements of the periodic table. Now what we are left with, we have completed S block, we have completed P, D, noble gases and F block elements. Now let's discuss about another term in our periodic table that is known as the diagonal relationship. So our next term is about diagonal relationship. Now what is diagonal relationship? The second and the third period elements in the periodic table show the diagonal relationship in respect to their properties. So this is known as diagonal relationship. So we have second group and the third group elements, and the elements we have are, here we will write the elements lithium, hydrogen, helium, lithium, beryllium, boron, carbon, oxygen. These are few elements, and the elements we have here is sodium, magnesium, aluminium, silicon and phosphorus. Here are few elements we have that is belongs to the second and the third group. So you can see here we have taken the two groups, that is second and third group. In this second and third group, some of the elements present will show the same properties in the diagonal manner. So how will they are correlated with each other? Lithium is going to show its properties with magnesium, beryllium is going to show its property with aluminium, and boron is going to show its property with silicon. These are the few elements which are diagonally related to each other. You can see here. These elements are diagonally related to each other. So if they are forming the diagonal relationship, we can say that this is the another characteristic of the modern periodic table. And why they are showing the diagonal relationship? Because with respect to their same properties. Because same properties in a diagonal manner. It has the same properties in the diagonal manner, so we can say that they are exhibiting a diagonal relationship. Now, the last element or the last representation for this block representation, we have the transuranium elements. So, which elements are known as the transuranium elements? The elements with atomic number greater than 92 is counted in the transuranium elements. So, the next topic will be transuranium elements. Next topic we have is about transuranium elements. So what actually are the transuranium elements? Elements with atomic number greater than 92. So we can write here elements with atomic number is represented by Z greater than 92. The elements that is having an atomic number greater than 92 are known as transuranium elements. These are transuranium elements. So these are few of the things about the block representation of this SPDF. So you can see that if you are going to learn about the block representation of these elements, it might be easier and helpful to you to get a better knowledge about these elements. So this topic is over for today. Now we will start our new topic in our next lecture, that is all about periodicity, that we will start in our next lecture. Thank you so much and have a nice day.